Hello there and welcome to Lower 6 Maths AOL. This is the Applied Practice Paper F, and here we're on question 6. The boat travels from A to B and then B to C. The displacement from A to B is minus 28I plus 80J. The displacement from B to C is 130I plus 15J. Find the total distance the boat travelled from A to C. Now the key word here is not displacement it's used in this question here, but distance. Okay, so distance is the magnitude of its displacement, or in other words, if we think about it in terms of minus 28 plus 80j, it's effectively gone left by 28 and up by 80. So we're effectively looking for this distance here, not this total left movement and then up movement. So you can see here what this forms, and that's a right angled triangle. So the displacement from A to B, and the way we would notate that is A to B with an arrow over it, and then some vertical lines either side, or the modulus of it, equals the distance to the move to the left, so that's 28 squared, add 80 squared, and you get your calculator out and you work that value out, because we're going to add it to the next one. So that's about 84.75. So it's moved to B, and then from B it's moved on to C. So from B to C, the distance travelled there is going to be 130 squared add 15 squared, which is going to give us a value of 130.86. And then for the total distance travelled from A to C, then we add these two results together. So the distance from A to C is equal to 215.62. So in meters, that's going to be 216 meters. Okay. Part B is find the angle of the vector from A to C makes with the unit vector I. So to get the vector from A to C, we need to do the vector A to B, add the vector from B to C. So we're going to add together our two vectors here. So it's minus 28I plus 80j, add on 130I plus 15j, and that's going to give us 102I plus 95j. Okay, so if we were to draw out a set of axes for this, it's going to be moving right by 102 and up by 95. So pretty equal there, really. Right 102, up 95. And what we're looking to do here is find the angle A to C makes with the unit vector. Now, I've drawn A effectively at the starting point here. I don't know that A starts here, but I know that C is going to be at a position of 102 right, 95 up from A. So to work out this angle here between this and the unit vector I, remember I is effectively the x-axis, what we need to do here is a bit of a tan calculation. Theta here, which is effectively the theta angle here, is equal to tan minus 1, or arctan of the opposite over adjacent. So that's 95 over 102, which is equal to 42.96. So we'll say that's 43 degrees. Okay, so there's 8 marks for that question.